Hey everyone, hello, welcome. We have a great program for you tonight with important aircraft information for every owner. I'm Kent Dellenbush with Cessna Flyer and Piper Flyer Associations. We are happy to present Bill Ross, Vice President of Product Support with Superior Air Parts. And do you want to improve your aircraft engine operations and extend engine life? Sponsored by Superior Air Parts and Aircraft Spruce and Specialty. Here's Bill.
Thank you, Kent. I'm sharing my screen with you folks now. And today we're going to talk about engine operations and extending engine life. If you folks can see behind me, there's a Cessna 182. I'm coming to you tonight from my personal hangar, and this is my family's Cessna 182. Um, and we use the airplane a lot. I understand what it takes to maintain an airplane and the cost involved in keeping an airplane. The last thing that we want to do is to reduce the engine life because we're not following and doing the things that we should with regards to operations. But tonight we're going to talk about that. Hopefully, we're going to clear up some uh, misnomers that you may have with regards to engine leaning and how to operate the aircraft. We'll go over some basic terminology tonight with regards to engine leaning that's fundamental for us to understand before we can begin talking about what's actually happening in the engine during the leaning process and during cruise, climb, and things like that. Just a very brief uh, note about me. I am the work in the product support department for Superior Air Parts, and been with Superior now a little over 5 years. Um, and I learned to fly at age 16. Um, right out of high school, got an airframe and power plant certificate. Went on and became a flight instructor and commercial pilot. And most of my career in flying was centered around charter, freight operations, and corporate flying. And the majority of my time is behind piston-driven aircraft. Um, Graduate from the University of South Alabama, um, and have worked in various capacities at another engine manufacturer in engineering, analytical, and customer product support. That's where I think my niche is. I certainly enjoy helping owners, mechanics solve problems with regards to aircraft. And certainly the highlight of my career is to be able to give presentations and answer questions and things like we're going to do tonight. So at the end, I hope that you do have questions, and hopefully we can clear some of these things up about engine leaning or some of these misnomers. Again, we're going to attack it from a very high level, very basic. Some of this stuff may be you may already know, but for the benefit of those who don't or may not have heard of these terms and things like that and concepts, I just ask that you bear with me. We'll get a little more in depth when we get to leaning charts and actually what's happening in an engine during the leaning process. So the engine leaning questions that I always hear is, should I run lean a peak? Should I run rich of peak? Well, there's no religion there. I think that there is a made up religion within the industry of those who feel that they can only operate lean a peak, and there are those who can only operate rich a peak, and subscribe to one of those respective religions. And the truth of the matter is that that's probably not right. There are times that we would fly Lena Peak. There are times that we would fly Richa Peak. There are aircraft and aircraft engine combinations that can't fly Lena Peak. There are aircraft and engine combinations that maybe Rich of Peak is not the best place to run. But there's a lot of confusion around what religion that one should follow. And so somewhere in between is where we get into trouble. We take a little bit about what this person says. We take a little bit about what this person says, a very tiny bit of what the manufacturer has to say. And we find ourselves for a recipe for causing problems when we're somewhere in between. We all want to go fast and we all want to go far. Believe me, I know what the cost of avgas is. I hear it from my wife every month about the avgas bill, and I have a set allowance. Sometimes I go over, but I try to keep it within check. But we all want to go fast and we all want to go far, and sometimes we can't have both. What I'd like to do is to tonight think about leaning the engine and managing our aircraft engines in a different way. And that is, let's operate them for maximum efficiency and durability. That's really what the name of the game is that we want to be as efficient as possible, and we also want to have the most durability. I mean, isn't that what everybody really wants out of their aircraft engine? They want to go from 0 since major overhaul to TBO and beyond without any unscheduled maintenance. We want it to sip on fuel. We want it to have lots of power. We want it to climb like a homesick angel, things like that. We all desire that out of the aircraft engine. But let's look at operating the engine for maximum efficiency and durability for the long haul. Now, if you have attended any of my seminars, and I do work for an engine manufacturer, a lot of my presentations, you hear me, I sound like a broken record about manufacturer recommendations. You'll hear me many times talk about manufacturer recommendations and the importance of following those recommendations. But let's think about it just for a minute. When it comes to engine operation, let's talk about the things that an engine manufacturer has to do in order to certify an engine. There are a lot of engineering hurdles that one has to get over. And the federal regulations are written to the point where it's very, very difficult to get an engine certified. So that's why we don't see a lot of technology that we enjoy in our own automobiles, such as auto leaning and timing changes and injection duration changes in some of the electronic controls that we see in the automotive industry, we don't see in the aircraft industry. And that's simply because of the cost to bring those things to market, to get over all of those engineering hurdles. But the respective engine manufacturer designed that engine. You can't just take an engine and let's say we're going to create an engine company and we're going to make a case and some cylinders and a crank, and we're going to put it all together and we're going to test it for 25 hours on a test cell. And if it doesn't come apart, we'll put it in an airplane. That's not the way it happens. It's very, very, very involved through the design processing and the engineering development testing of every single part that goes into that engine. The certification requirements that an OEM has to go through is extraordinary. The Federal Aviation Administration sets forth in Part 3349 the endurance testing requirements and certification requirements for engines and components parts, and it is very, very difficult to get those through. It's a long haul process. And by the way, the engines have to be tested at their maximum engine parameters. In the case of a Continental engine behind me, that 0470R was certified with the cylinder temperatures at 460 degrees. It had to be configured at 460 degrees for 450 hour durability testing. Calibration is another big engineering hurdle to get over that the OEMs have to do. Altitude, performance, and the big thing that we're going to talk about tonight when we talk about engine leaning is detonation margins. Detonation margins are required by 33.49. They're required by the engine manufacturer to keep you free of detonation during the engine leaning process. And again, if you follow manufacturer's recommendations, you won't and can't detonate the engine even on the hottest of days. But we'll get into that a little bit more as we go. In order to understand engine leaning, I think there are a few terms that we must understand. They're fairly basic terms. I included one, and that's the red zone, the red fin, because I want to talk about that. I know there's a lot of confusion as to what that means. But the big terms are air-fuel ratio, maximum recommended cruise, and again, I caution you not to confuse this with max continuous power. There's two different terms, maximum recommended cruise, and I'll define each one of these respectively as we go here. Red zone and red fin, we've all read the articles about don't lean in this area because if you do, the sky will fall and the world as we know it will end. And you could detonate. Detonation is the next term. We need to understand what detonation is, how to recognize it, because you can't hear it like we do in our car. You know, when we're in our automobile and we're accelerating up a hill and you hear the pinging, that is detonation. That's not the valves clicking or rattling. That's not the piston rings clicking or rattling. What you're hearing is a resonance of shock waves that are propagating through the engine and resonating out. You're hearing it in the form of a ping. We can't hear that in an aircraft engine with all the noise and all the wind noise and the propeller noise and engine noise. You can't hear it. And the noise attenuating headsets these days do a really good job, so you wouldn't hear it anyway. Engine parameters and durability. We understand engine parameters because cooler is not always better. I know we think hot is bad in an aircraft engine and cool is good, but we can actually do damage to our engines if we're being too kind to them, and that can affect durability. We'll talk about engine operation terminology from an air-fuel ratio point of view. An air-fuel ratio is simply the amount of air to the amount of fuel. And the thing to remember is that as we lean the engine, a leaner air-fuel ratio will result in a higher temperature as the mixture is combusted or as the gas and air, or fuel and air, are burned. Most of our engines that we fly produce the maximum power just rich of stoichiometric. Now, what is stoichiometric? We have three different concepts here or items to talk about. A lean mixture, which is 15 parts of air to 1 part fuel, 14.7 to 1, or 14.7 parts of air to 1 part fuel. That's thought to be or referred to as a stoichiometric mixture. And what that means is that during the combustion cycle or combustion process, all the molecules of air, all the molecules of fuel are consumed within the process. But that's not necessarily the most efficient place for us to run. And then a rich mixture would be something on the order of 13 parts air to 1 part fuel. So again, the key here, and when we start looking at the charts at the end, we'll see where peak is and where stoichiometric is. But it's one thing we need to remember is that our aircraft engines normally produce maximum power, or you may hear it referred to as best power in most of our pilot operating handbooks, slightly rich of stoichiometric. So it's not It's not stoichiometric where we find the best power. It's actually slightly rich of that. Maximum recommended cruise. Remember I cautioned you to be very, very careful on this. This is not maximum continuous power. Maximum continuous power is the power setting that the engine can run at full rich 24/7, 365 days a week. Just everything forward, unless some engines may have a 5-minute limit, but that's maximum continuous power. I'm not talking about that tonight. I'm talking about in our pilot's operating handbook, we will find maximum recommended cruise. And this is the point up to, but not exceeding that manifold pressure or RPM combination. Full leaning authority is safe, it's allowable, and the engine is tested for durability, and it's also free of detonation, even if our cylinder head temperatures were at 460 for a Continental or 500 for a Lycoming. We couldn't detonate the engine. So maximum recommended cruise. So remember, if we're at maximum recommended cruise or below, we can basically do anything we want with that red knob and we can't hurt the engine. This is where people get into some trouble, is they're leaning and cruising and leaning the engine above what the manufacturer has tested the engine to be safe and durable and free of detonation. And that's where we can get into trouble. Where do I find maximum recommended cruise? In your pilot's operating handbook. Now, a lot of pilots operating handbook don't say in the table of contents, maximum recommended cruise, page 57, and you go to page 57 and it says 25 inches of manifold pressure, 2,500 RPM. Some do, or some may say max cruise power is 65% or 75% or 85%, depending upon your respective engine and your respective airframe. But when we look in there, if it's not defined as such, we look at the power charts. And in those power charts, you will see at 2,000, 3,000, 4,000, 5,000, pick a number, different altitudes, you'll see manifold pressure and RPM combinations, expected fuel flow, percent power. When the chart ends at the top, that's maximum recommended cruise power. Usually in 182 is somewhere around 72, 74%, depending upon the altitude. But that's defined in the chart, the cruise power chart for that particular airplane. You have to consult your aircraft to find exactly where your max or what your maximum recommended cruise is. If you're an experimental aircraft, then you don't have the luxury of flight tested data by an engineer who has established that. You have to refer back to your engine data and do some flight testing on your own to find where the engine, you should operate the engine. We've all talked about the red zone, red fin. We've read all the articles and all out there about there's a red fin and a red zone during leaning. But the thing that we need to remember, folks, tonight is that if we're operating at or below that max cruise power setting that I'm talking about, set forth in our pilot's operating handbook, there is no red zone, because you can do anything you want with the mixture and you can't hurt the engine. In fact, Continental publishes a bulletin that says in any Continental that at or below 65% power, you can run the engine at peak if you'd like. And there may be cases that you want to do that, such as a flight school or something like that's having trouble with lead, having trouble with combustion deposits and things like that. That's why it's not one single religion as to where to run the aircraft engine. But the thing we need to remember about the red zone is that at or below max cruise power setting, there is no red zone. You have full leaning authority of the engine and you can't hurt it by leaning. If you're above that setting If you're above, if wide open, you're in a turbocharged engine and you've got it above, I know the manual says don't, lean above 30.5 inches, but I think it'd do better at 34 inches. No, that's where you get into trouble. That's where the engine's not tested. So be very, very careful. Make sure that you review your pilot's operating handbook or your engine manual to establish what is the maximum cruise power setting for your respective aircraft. And what we're trying to avoid is detonation. Remember, I said you can't hear detonation. It is a very, very detrimental phenomena that can occur in an aircraft engine. And if you look at the picture of that piston in the slide, you can see that the periphery of that piston is actually eroded away. That's thermal erosion because it got so hot. You'll also see that there's very, very little combustion deposit present on the piston top, another characteristic of pre-ignition or detonation. And this is a very key to understand. Detonation is an explosion that's happening in our engine, not a controlled burn. When we talk about the 4 cycles of an engine: intake, compression, power, and exhaust, a lot of folks visualize that, intake, the intake valve opens up, draws in a fuel air mixture, we compress the gas, the spark ignites, bang, and it blows the piston down. That's not really what happens. It's more of a controlled burn. It's a lighting of the fuel air mixture. That fuel air mixture expands and gives a nice push on the piston that we understand as horsepower. Detonation is when the piston comes up, there's this spontaneous explosion that happens very, very rapidly, very, very quickly. So all of the heat is contained within the combustion chamber. The flame front does not have any time to propagate down through the tailpipe. And that's why the pressures and the temperatures go very, very high. Cylinder head temperatures can go extremely high during detonation. In fact, I was part of a test where we purposely detonated an engine by cracking insulator cores on spark plugs. And I saw cylinder head temperatures on a Continental engine of 890 degrees. And so that's a real serious event that's going on, and that will melt pistons. Cylinder head temperature goes up, exhaust gas temperature goes down. And you would think that's kind of counterintuitive, but think about it for a moment. Again, in a detonation event, the piston comes up and there's an explosion that happens very rapidly all at one time in this confined space. So all the heat transfers into the head. Cylinder head temperature goes up. The exhaust gas temperature drops down because the flame front doesn't have time to propagate down and kiss the exhaust gas temperature probe like it normally should. So the temperature of the exhaust gases start to go down, but the cylinder head temperatures go way, way up. You can't get into detonation assuming all things are equal and that we don't have contaminated fuel and we have our timing set correctly and things like that. But I'm talking from just a pure leaning aspect. If you're at or below that max cruise power setting that I talked about, you should have no problem and never ever experience detonation as part of a leaning process whatsoever. Here's an illustration of normal combustion and the push as illustrated. It's probably more of an explanation than I did in the previous slide. And the explosion in detonation on the right side is a hammering of the piston. Very serious event. If your engine does have a detonation event, it's not a time to just change the cylinder and piston and go on. It's very, very important that the engine be disassembled completely and inspected for damage caused by detonation. So it can crack crankshafts, it can bust connecting rods, it can bust connecting rod bearings. It can extrude them. There's a whole lot of things that can go on as a result of detonation. Now we're going to jump into what I think is my favorite part of the leaning when we talk about engine leaning. And this is a very simple chart that I like to use to illustrate what's happening in the engine. So if you folks can see my mouse, and I hope you can, this top line in red is the exhaust gas temperature. So peak exhaust gas temperature would be right here where my cursor is, okay? And this would be lean peak. We're going to be lean peak when we talk about things on this side of the chart. So this is rich peak, this is peak, and this is lean peak. Think of the down at the bottom, you can see it's rich and lean. Rich on the right side, lean on the left side. Cylinder head temperature is in blue. Again, we can have a peak cylinder head temperature, and peak cylinder head temperature is here where my cursor is, and this would be on the lean side of peak cylinder temperature. Horsepower curve, you notice that it comes up and then drops off. About right here is max power, that if we lean the engine, we'll see best power. And if we take the cursor and go straight up, remember I said that best power is somewhat rich of stoichiometric. Stoichiometric's right in here, and best power is found somewhere just rich of that. And then probably one of the most important things is you'll hear engineers refer to this line as the brake specific fuel consumption curve. Some will call it the SFC or the FC, but that is basically how efficient we are with the engine. How much energy are we deriving for a given volume of fuel? So to be extremely economical, we want to be at the lowest point on this curve as we can be. The lower the number, the more efficient we are for a given volume of fuel in the output of the engine. So in a full rich condition, the engine's not going to be very efficient, as you can see here in the chart. In the rich condition, also the horsepower won't be everything that it could be because the engine is rich. Why do you think the engine is rich? It has extra fuel to protect it against detonation. When we take off in the engine at full power, we're above max cruise power setting. We're at maximum power. So the manufacturers design extra fuel to throw at the engine to keep things cool, and in no way can we get detonation at those power settings. If you fly a fuel injected Continental engine, it's very important that your fuel system be calibrated every annual so that you have adequate fuel to keep the engine cool. So let's look what happens when we start to talk about leaning with regards to this chart. The first thing I like to talk about is the full power takeoff in a full rich condition. The exhaust gas temperatures are cool because the engine's fat. What I mean by fat, it's drinking a lot of fuel. The CHTs are cool because it has low exhaust gas temperatures and we're feeding the engine a lot of fuel. The horsepower is not everything that it could be because we're feeding it more fuel. It's slightly rich. There's a reduction in the horsepower, or a limit in the amount of horsepower that the engine can put out at that particular mixture setting. And then look at the brake specific fuel consumption. It's not very efficient because it's full rich, a lot of fuel going through it, keeping it cool. So the brake specific fuel consumption is very, very high. We're not very efficient, and that's not where we want to run our aircraft all the time. As we begin to lean, remember from one of the terms, air-fuel ratio, that a leaner air-fuel ratio results in a higher temperature. So as we begin to, we set our max cruise power setting, we've taken off, we'll set our max cruise power setting, whatever that may be in your respective engine manual. In a Cessna 182, it's somewhere in the 2300, 22 inches of manifold pressure type of scenario. In turbocharged engines, it can be higher. It can be sometimes 75, 85%. You have to consult your pilot's operating handbook to get there. But remember, as we lean, the temperature is going to go up. So as we lean the engine, we start to slide up the scale. As we lean, the first thing we're looking at, if equipped with an engine monitor, we see exhaust gas temperatures start to rise. For those who have the luxury of having a exhaust gas temperature gauge on each cylinder, you can watch each cylinder rise as we begin to lean. All of a sudden, you'll have corresponding cylinder head temperatures going up as well. And as we start to lean through best power, which is that perfect setting to gain the most power. It's not stoichiometric. It's rich of stoichiometric, but this is where the engine is developing the most power, the most twist on the crankshaft, and you should see the highest indicated airspeed on the aircraft. Look at the brake-specific fuel consumption. It's starting to become efficient because we're going fast, but we're not in a best economy mode yet. It may be for some engines that this is the place to run. For example, Cessna 185s are utilitarian type airplanes. They have generally, there's just not people that are cruising in a Cessna 185 just out joyriding on a Sunday. They're hauling fish. They're hauling fishing rods. They're hauling hunting gear. They may have a deer strapped to it somewhere in the back. It's loaded, and the most efficient place to run the engine in those aspects is in the best power mode as depicted on the chart here. Brake-specific fuel consumption is not the best that it can be, but if we were to lean further and lose some power, then the airplane may lose a lot of airspeed, and that doesn't make any sense. I'm just throwing out scenarios that you can use when we talk about leaning as to whether we pick one or the other, whether we pick lean peak or rich peak. So as we lean, we continue to lean. We'll go through peak EGT. See, we're on the rich side of peak. This is peak, so we continue to lean until we're on the lean side of peak. It's easy to find peak exhaust gas temperature. When you're leaning your engine, and let's say you're lucky enough to have a multiple point exhaust gas temperature gauge, when we're leaning and we're going to set power for this aspect, which is best power, we would lean until the first cylinder peaks. When the first cylinder peaks, we note that temperature and we enrichen the mixture to this point until it's somewhere in 75 to 125 degrees rich of peak exhaust gas temperature is where most aircraft, most engines, aircraft combinations, that's where you find best power. Now, some may be 50, some may be 135, but generally they are somewhere in the 75 to 125 degrees rich of peak. So again, we lean until the first cylinder that peaks, and after the first cylinder peaks, we note that cylinder and we enrichen that cylinder, cool it off, 75 degrees rich of peak, pick a number, and that's where we lean to. When we find peak, and we're going to fly lean a peak, and we're fortunate enough to have an exhaust gas temperature gauge, then we lean until we see the last cylinder peak, and we continue to lean to cool that cylinder 50 degrees lean a peak or 60 degrees lean a peak or whatever the respective engine manufacturer recommends for best economy in a lean of peak mode. Now, as we go lean of peak, there's a couple of things we need to point out. As we approach or as we go through the peak exhaust gas temperature, things start to happen pretty rapidly in the engine as far as cooling, you can see that the cylinder head temperatures start to come down. The exhaust gas temperatures coming down. And look what happens pretty dramatically to the horsepower curve. The horsepower has dropped off. And then in this particular case, the brake specific fuel consumption is right. It's as far as we can be on the brake specific fuel consumption curve for efficiency. We're at the bottom, and that's a good place to run. It's not always the place to run with your respective aircraft. Some aircraft won't run lean to peak. This airplane behind me will not run lean to peak. There's just no way that it will happen. Yes, I've heard about mechanics and folks tell you can pull a little carb heat and you can do this and that. It's not worth it to me. This airplane, we use it to go places, so I'm running in a best power mode in this application to get there. So this is the basic terminology for leaning. Again, you find peak, the last cylinder that peaks, we lean to whatever the respective manufacturer may say. Let's pick a number, 50 degrees lean to peak. You take that last cylinder that peaked, we continue to lean and cool it down 50 degrees. Don't worry about the others. And that's where we operate our engine. Now, let's say you don't have an exhaust gas temperature multi-point whiz bang. Can you still run lean to peak? Let's pick an airplane. Can you still run lean to peak? If the engine airframe combination does have a lean of peak power setting and is approved for lean to peak, you can. And you can actually close your eyes, set max cruise power setting, and lean the engine until you feel a deceleration. And folks, when you do that, you'll be very, very close to this point here on the lean to peak curve. How do I find best power? I start to lean until I see the highest indicated airspeed. Or if I'm in a fixed pitch propeller, the highest RPM. And that's how we find that even if we don't have all the whiz-bang stuff that a lot of our engine monitors afford us. Again, the airplane behind me does have an EDM 700. The aircraft was equipped with that when we acquired it. It's not something that I think that I need to lean the 182. I can do very, very well by leaning this airplane until the engine stumbles and enriching it until the engine runs smooth. And when it does, I'm pretty close to where I want to be, even with the engine monitor. A lot of people, a lot of flight instructors have said, increase the mixture until the engine runs smooth and then give it a twist for the hell of it. I've searched many POHs throughout my life, and I've never seen the term twisted again for the hell of it in any POH. But the thing is that we want to lean it and then until it runs rough, and then enriching it till it runs smooth. And that's generally a good place to run with carbureted aircraft such as this. Fuel injected engines, some of them have the ability to fly lean to peak and do so very well. And we can enjoy this curve here that I have pulled up here and be very, very efficient. Some aircraft, particularly Lycoming powered aircraft, the best place to run, the most efficient combination is at peak exhaust gas temperature. Some Continentals, let's take, for example, a Cessna 402, very, very complex airplane, very, very high output, turbocharged 520 VB engines. And that aircraft, its best economy is at peak EGT. Well, you say, Bill, you're going to burn the engine up running at peak. No, I'm not. Remember, at or below max cruise power setting, I can't hurt the engine. And Cessna and Continental have in their engineers have determined that, and through all of the testing through 3349, that I can't hurt the engine, and the most efficient place to run is at peak in that engine. Again, I'm trying to drive home that we need to consult our pilot's operating handbooks for our respective aircraft as to whether or not we should run it rich at peak, lean at peak, or at peak. And there may be times when we want to run either or. It's not, again, not one religion. There are times when you may want to run best power. There are times, as I said previously, I've worked with flight schools who've had chronic problems with lead fouling and carbon deposits and burned valves. Burned valves. Burning valves because they're too rich. Burning valves because they're accumulating combustion deposits. Those combustion deposits are holding the valves open and allowing the valve to be torched at every combustion cycle. And when you go into a flight school and you tell a flight school that's had problems with burned exhaust valves, and you tell them that we need to lean more, they look at you like you have three heads, because how can that be? We're too hot as it is. No, sir, we're not hot enough, and we've got to get that stuff burned off. So in those cases, the place to run is at peak exhaust gas temperature. Mission work like aerial photography and things like that, those aircraft that are flying at 55% power, 50% power, that are taking pictures and things like that, those folks need to be leaning to peak exhaust gas temperature just to affect more heat in the engine, get the oil temperature up, which is what we're going to talk about next, is being kind to the engine and not being unkind to it in just a minute. Here's where we get into trouble with the, going back to the first slide when we were talking about somewhere in between. I know you've all have read many articles that there's a demon that lives out there in the cylinder head temperature world, and it lives somewhere at 380 degrees and above, and that if the engine experiences something more than 380 degrees, that we're going to hurt the engine or reduce the engine life. I feel calls daily about that. Hey, I read this article and so says I never should exceed this amount, so I'm going to be really, really kind. And I've been running way cooler than that. And I want to get into that for just a minute, because a lot of this happens when folks are running lean of peak. One way that we can cool the engine off is to lean it further. If you look at the left side of the chart here, you'll see how things rapidly cool off. So if Lycoming or Continental make a recommendation that 50 degrees lean of peak is the place to run, but my cylinder head temperatures are 390 degrees and I want to make them cooler, a lot of these people are leaning the engine further just to cool the CHT down. And this is what's happening in a lot of engines that I see today. And a lot of operators, I fly with a lot of pilots, and I see this all the time. Notice I'm taking a total disregard for what the manufacturer says, and I begin to lean further. My exhaust gas temperatures go down, my cylinder head temperatures go down, because I read that article that 380 is bad, so I'm going to lean it further and cool it off. Look what happens to cylinder head temperatures. It cools dramatically. Horsepower falls off. The more we twist that red knob in the lean mode past peak, the more we're going to reduce horsepower. And look what happens to our brake-specific fuel consumption curve. It starts to go almost straight up the line because we're now grossly becoming inefficient. Along the way, we have lost the efficiency, and we have also caused problems with cylinder head temperature, which is vital to engine cooling. Efficiency goes out the window. Oil temperature starts to tail off because cylinder head temperature is so cool. Oh, but I read this article that, 380, so I've been targeting about 340 because I want to be good to my engine. Well, at 340 degrees, cylinder head temperature, you may not be getting 180 degrees oil temperature. Guess what that can do? Lead to corrosive attack in the engine. All the oil companies, all the engine manufacturers that I'm aware of really would like to see 180-degree oil temperature, systemic oil temperature sustained for cruise flight. If your aircraft engine is not running at 180, then you could be running it too cool. You could be running it too low a power setting. You could be leaning it too aggressively, too far past peak, or you may not be leaning it enough. But oil temperature is very, very important, and we need to get that at 180 to cook the unwanted acids and water and things like that out of the oil. You know, we see more over the last probably 10 years with the rising cost of aviation fuel, maybe even almost 20 years now, more corrosive attack to the cam and lifter interface, spalled lifters than we ever had before. I feel a lot of that is due to too low of an oil temperature, which leads to corrosive attack, low horsepower. It can even lead to engine roughness. I've seen pilots that are so compelled to keep cylinder heads cool that they're actually running in an area where the engine is running rough, and that can be detrimental to piston rings and the piston and ring cavitation and things like that all along the way. So what happens in the industry now is I think that, you know, guys are sitting on a park bench, and one talks about an article that he read that 380 is the place to be. And one guy says, well, if 380 is good, 350 must be better. We all think that way. And if 350 is good, then 300 must be the target for my engine. That's not the case, and be very, very careful in thinking like that, because you can do irreparable damage to your engine by being too kind to it. So we want to be very, very careful about our oil temperature and things like that. This is a illustration of good combustion pressure and low combustion pressure. When we lean further than the manufacturer recommends, and I'm talking about in the lean of peak mode, we'll set up a scenario that's on the right side of the screen. If you can see that close enough, the good combustion pressure helps squeeze the ring against the cylinder wall. If you look at the cross section of a piston ring for an aircraft engine, it has a pitched wedge, or what we call a semi-keystone design. And so as the combustion pressure contacts the ring, it loads it on the ring land. That's a piston ring moving back and forth. And this is the piston here. And this is the ring, what I refer to as the ring land. So it moves the ring up against the cylinder wall. If our combustion pressure is low because we've leaned too aggressively chasing cylinder head temperatures, look what happens to the ring. It can become unseated off the land, and now exhaust gas byproducts can get around the inside of the ring and leak down and start to cause problems with the oil control rings and rings below the compression ring area. That can lead to oil consumption issues, accelerated wear, and not to mention we're putting more. I know that a lot of people think, well, I'm running lean to peak and I'm running aggressively lean to peak, so there's no way that I'm loading my engine up. But yes, if you set up a scenario like this, you're loading the engine and laden, and the oil is becoming laden with combustion byproduct because it's escaping around the ring. So be very, very cautious and careful about that. Owners and operators should look at manufacturer's recommendations, look at it from how to operate the aircraft, what maintenance should be performed. If you hear hangar chat or talk or people coming up with suggestions to how you should operate your engine that's not in concert with your respective manufacturer, I suggest that you question that validity, and you may want to consult your respective engine manufacturer. I know that we field calls on leaning and operation all the time as to how you should lean your engine. It'll only lead to safety, reducing the cost of the owning the engine over time, and certainly improved reliability. Now I'm going to say a few words about Superior Air Parts, and I've gone through this pretty quick this evening, but I wanted to save a little extra time for questions, so I'm going to finish just a little quick, and I hope you guys, our folks, have plenty of questions. I anticipate that you will, because I know this is and can be a very confusing situation. Superior Air Parts, we are the manufacturer of the Millennium cylinder. A lot of people get that confused. I've heard people say, I want Millennium cylinders, I don't want Superior cylinders. Well, we do make the Millennium cylinder, and we have a 37-month parts and labor warranty on our cylinders. And that's the leading warranty within the industry. We have several thousand FAA, PMA approved parts available, and we have many distributors all over the world for which you can purchase our parts. Our website is a very good place to find information. Also, while you're there, I invite you to go to superiораirparts.com, and you can click there. You'll see Engine Management 101. And I was fortunate enough that Superior Air Parts published a little book that they challenged me to put together, which is a collection of a lot of these thoughts about engine leaning and engine care and things like that. And Superior put that in a nice little book, and we made it free to customers. You can click there and download your free copy, digital copy of Engine Management 101. I hope you find it helpful. A lot of the questions, if we don't get to your questions tonight, a lot of the questions on leaning are certainly answered within that format, where we have, we'll have more time to look at it. Also, while you're at our website, you can look at technical support, hover over technical support to see if Superior manufactures parts for your engine. So you hover over that technical support here and then choose Superior eligibilities. And you have multiple ways to search by Lycoming engine types, by Continental engine types, or you can search by part number to see if we have eligible parts for your engine. When the part comes up that we do, you can see the eligible models below, and the current eligibilities are listed. There's also other kits with that part number, and then the PMA document approval is also part of that as well. Each part has a breakdown of what's in it. For example, a Continental C90 cylinder assembly, you can see all the parts that are included with that. And I invite you to go to our website and play around with it a little bit. And certainly we want you to download that free copy of Engine Management 101. And I thank all of you for taking time out tonight to listen to me go on about engine leaning. I know on behalf of Superior and all of the employees at Superior, we thank you for your time this evening. We thank you for your business if you are a customer of Superior. And at this time, Kent, I'll take questions.
Me unmute. Can you hear me, Bill?
Yes, sir.
Excellent. Okay, let's see here. We got a bunch of good questions here. Michael Zapta. If you have a long runway, is there any reason not to take off at lower power settings, somewhat closer to max continuous cruise?
No, there's no reason to do that. I've heard people ask that before. Should I roll the prop back, or should I take off at a lower power setting, closer to max, or to what would be maximum continuous cruise? And no, that could be very, very dangerous, even if you had 2 miles of runway. The runway is not the problem, or obstacles is not the problem. Let's say you were at Edwards Air Force Base. The problem comes in is that you can lug the engine. You can overheat the engine because you're not moving enough air through it. You're not climbing at a good rate. And so most engines, and consult your pilot's operating handbook, but most engines are designed to take off at full power. There are a few that have a 5-minute limit. We need to be cognizant of a 5-minute limit, but I would never take off at a lower than takeoff power as set forth in my pilot's operating handbook. You're not going to do the engine a favor.
Okay. Let's see here. Jamie has a question. How long do you keep the max power off after takeoff? And I normally pull back, power back and prop at about 1,000 feet. He's got an 0470.
Okay, I have an 0470, and there's nothing wrong with that practice. I climb the Cessna 182, and it sounds like maybe this person has a 182 or something similar. But to give you an idea what I do, I climb at full power, full RPM for takeoff, and then at about 500 feet, I will move the prop, roll the prop to 25, keep the throttle wide open, and I climb to altitude. I don't have to do that. The airplane can climb at full throttle, full RPM, full rich, and not have any problems whatsoever. I do that for passenger comfort, and I got that from the days of being a charter pilot, where we were cognizant of noise. This back in the 80s, we didn't have the advent of engine, noise attenuating headsets. So it was something that we did to reduce the noise in the cabin, and it's kind of stuck with me, and I do it as a matter of habit. It's not something that you have to do.
Okay. Let's see. Juan has a question. Other manufacturers state that for maximum engine longevity, run the engine at 65% power or less. Does Superior share that opinion? Can I run 75% ROP and not worry about the longevity?
And to that question, it's a very good question. I've heard that before. I'm gonna go back to, and I know I sound like a broken record. You never want to lean the engine above your max recommended cruise. Now, if your aircraft is capable in your pilot's operating handbook, it has a max cruise power of, let's say, 75% and below, you're not going to hurt the engine by running it at 75% power and leaning it. If your max cruise power setting is 70 or 72 for your respective engine, then you would be above max cruise power setting, and now you're sort of a test pilot. But I think the notion that people are thinking is that if I'm running it at a little less power, I'm being kinder to the engine and it will last longer. That's not necessarily true. In fact, at 65% power and below, we can start to get into some cooling problems in certain airplanes. And when I say cooling problems, engines that are running too cool. That's why Continental published a bulletin many years ago that said at 65% power and below, you could run at peak exhaust gas temperature. And that was to give an approval and get people to start running their engines there to get the oil temperature up. But again, consult your respective pilot's operating handbook. And I run our aircraft at max recommended cruise. I don't run it anything less than that. Because I don't think that you're doing any justice to the engine or providing any more life running it any less.
Okay, thank you. Jimmy has a question. Wait a minute. In order to reduce condensation damage, what is your opinion on using oil additives? He had a discussion with a major rebuilder who does not recommend using it in new rebuilds because it can cause valves to stick on lower time engines.
Very good question. I've heard that for a long time. You also got to know, Jimmy, that each week and I'm sure the OEMs other OEMs, Continental and Lycoming as well as Superior, have a snake oil salesman that comes and tells you that he's got this motor honey, and if you dump it in, the engine will run forever. Um, there are several credible oil additives out there that I think are very good. I'll tell you a quick story. At Oshkosh one year, I had a technical representative was with me, um, and a gentleman came up and asked about CamGuard specifically. And the tech that I was working with said it's snake oil, don't use it, wouldn't use it, and the guy walks away. It didn't sit well with me, that answer, and I told him that I think you'd be better served to answer that question in a way that we haven't tested CamGuard, and therefore we don't know its effects. As a result of that, I actually entered into a test with a CamGuard with a number of engines, and the results were very promising. I actually left that manufacturer before I concluded the test, but I don't know that there's anything. I'm not seeing any scientific data that that it will allow valves to stick or cause any problems. One of the first things that we had to do as a manufacturer is determine that the use of that product wouldn't hurt the engine, and that came very, very quickly, that it did not hurt the engine. It does have very good promise, and I would, even though Superior doesn't approve any additives, it's not that we are anti-additive. It is that we've not performed testing in order to stand up here and say it's good. I would suggest that you look at the respective engine oil additive manufacturers' data. In the case of CamGuard and some of the others, they have very good engineering data, and consult those people and make an informed decision on that.
Okay, thank you. David has a question. Does increasing or decreasing RPM slowly help engine life?
It's a very good question. With regards to increasing and decreasing engine RPM, boy, that is a pet peeve of mine. Anybody here at my little airport that I live at will tell you, as a flight instructor, if I see a student or anyone making abrupt movements of the prop control, I kind of cringe, typically from high airspeed where we're pushing the prop forward and we have the propensity to over rev the engine. That's like fingernails on a chalkboard to me. But the detrimental effects of moving things too rapidly can be effect on the propeller and on the torsional dampers or the counterweights within the engine if we are accelerating, decelerating too quickly. Most pilots are not slamming the RPM forward. They're off the governor, what I call off the governor, in the below the green arc, turning base or turning final. You can move, do anything you want with the prop because the power's back enough where you're not going to over rev the engine. But I would avoid rapid movements just so that we don't detune counterweights and we don't cause issues with propeller components.
Okay, great. Now, this is kind of going to go back to the question with the oil CamGuard product. Changing oil is a lot easier than changing oil and the filter. Michael says that he changes the oil at half the normal recommended intervals to extend the engine life. His partner in the airplane feels that if you change the oil, you need to change the filter as well. So they do not change it as often, the filter. If you change the oil more frequently than what is recommended, is it okay to change the filter every other time?
Well, it's probably going to go against the grain of your in your respective engine manufacturer as far as at an oil change, changing the filter. I know a lot of pilots that are and owners that are doing that. An oil change is great for an engine. It really is. The consequently, the best indicator of internal engine health is an oil filter. And in any of my aircraft, everything that I have except the Cub, the Piper Cub, is equipped with an oil filter. I change the filter at each time because I want to see how the internals of the engine are functioning. And the best way to do that is cutting the filter. Um, if that practice is not going against the grain of the recommended maintenance um, from your respective engine manufacturer, I guess you could go ahead and do it. But I look at an oil filter as that ounce of prevention worth a pound of cure. I'd hate to have a problem because I didn't look at the oil filter. And maybe catching an event early would go a long way in safety, number one, not having an engine problem in flight, but also if there's something happening in the engine, the quicker we catch it, the better off we are if we need to inspect and repair as necessary, overhaul the engine. We're just going to be a little better off. So my personal recommendation, and I don't like to give recommendations. I like to, everything I like to say and do is predicated on engineering data, but I would think that probably goes against the grain of your engine manufacturer, and I probably would change the filter just so I could see what's happening in the engine.
Okay, makes sense. Okay.
You're already dirty anyway. You might as well get a little more dirtier with a filter.
And for the cost of a filter, what they cost versus possible engine
Correct.
breakdown, I would probably take that advice. Ivan, his question is, what could cause high cylinder head temps, 380 to 400 on takeoff, and then it goes down on cruise as measured with a EDM 830. He's got an 0360.
When he's climbing and the temperatures are going up, that's a function of airflow, it sounds like, because when he sets up for cruise and we're moving more air through the cowling, the cylinders are cooling off. Doesn't sound like, and I'm asked this question all the time. I've got this cylinder that's running at 400. What do you think's going on? The rest of them are 350. 9 out of 10 times that's an airflow issue. But I tell people that if you've got a cylinder or a couple of cylinders that are running much hotter than the others, the first thing we want to do is ensure that there's nothing anatomical going on inside the cylinder. Best way to do that is perform a compression test and a borescope inspection and look for signs of scuffing and scoring and heat signatures on the cylinder. If we don't have anything like that and the structure of the cylinder is sound and we have no signatures like that, then it's generally airflow related, or it could be fuel delivery related, that cylinder is just not getting the fuel. In the case of a fuel injected engine, it could be a clogged nozzle, it could be a host of different things, could be the fuel system calibration. In the case of his carbureted engine, it's probably airflow. And what I would do is look particular attention at the baffle seals, make sure that they conform to the cowling, and also any cracks and crevices in the baffling need to be sealed with a really high quality RTV, and all those little bitty seals, those little small seals and cracks can go a long way in elevating temperature. And inner cylinder baffling, make sure the inner cylinder baffling is in position, that it's installed correctly, and there's no bird nests living in it too. I have actually gone on service calls where, oh, how's the baffling? Well, I got a high cylinder temp. Well, how's the baffling? Oh, it's perfect. And you go out there and you're digging bird nests out of the inner cylinder baffling. So make sure all that's clean. Okay. And that's probably airflow.
Okay. Daryl Caldwell, he's been to our gathering a number of times. Daryl wants to know when Superior will develop and sell the Lycoming IO360 angle valve cylinder assemblies?
People ask me that all the time, and I tell them Thursday.
Okay,
I don't
Thursday.
know.
Okay.
I don't know what Thursday. We are always bringing new product to market, and
Yeah.
certainly there's a desire for us to bring the angle valve cylinder. I don't have a date and time that I can give you, and I'm just being funny about Thursday. A lot of people ask me, when are you going to fly your Ronca Champ project? And I always tell them Thursday because, don't know what Thursday, but we recognize that there is a need, and again, we're always bringing new product to market.
Okay, yeah, I'm sure Daryl will be watching. Ian, when leaning and I reach when leaning and I reach peak on cylinder on my EDM and then start to enrich, the temperature goes up before it drops, which is the temperature I target. He's got a turbo 210.
Yeah, that's not uncommon in a turbocharged engine for it to do that. When he found peak, when that temperature began to go down, that should be the benchmark. When he enriches, it is not uncommon to see it spike up a little over. Um, I wouldn't pay that any attention. Again, the first number that he saw where it started to go down, that should be his reference point for peak.
Okay, okay. Let's see here. Steve's, you talked about oil temps. What part does oil weight play in that issue?
Um, oh, you,
So oil weight versus
oh,
to the oil temp.
yeah, and I think the point here is that they're trying to, or the question is, do I use a 40 weight oil to affect a higher temperature, or do I use a 50 weight oil to affect a higher temperature, or do I use a 65 or whatever?
Right.
Again, that's that's a very good question. It's never been something that I have researched with any of the oil companies, and I work very closely, and Superior does with the oil companies. Um, go back to your operator's manual for the engine, your aircraft, and use the correct weight per the outside air temperature or the ambient air temperature that you're going to be experiencing. 40 weight oils should only be used in those extreme temperature situations as opposed to 50 weight oils or whatever. So I wouldn't try to change weights in oil to try to get the temperature up so I could run my cylinders cooler. I would stick with the recommendations of the oil weight based on the temperature and then try to get 180 sustained, whatever that may be.
Okay. Juan has another question. He runs his engine at peak EGT all the time. Might components downstream of the engine, like the exhaust, have a decreased life?
No, the short answer is absolutely not. Again, if he's at or below that max cruise power setting, there should be no problem to exhaust components or anything of that nature.
Okay.
He could run at a higher power setting is probably, I mean, like even full rich and full power, those exhaust component temperatures are probably higher than he is at his max cruise power setting and at peak exhaust gas temperature.
Another question is, you had mentioned one of the factors of detonation is an engine timing. Can you explain this?
Yes, engine timing or improper engine magneto to engine timing can lead to detonation, and it usually happens with mistiming in the advance curve. I'll give you an example. A few years ago, I had a customer that had a detonated piston, much like you saw in that picture in the slide. And the mechanic and the owner called me and reported a um, defective piston, in that they wanted us to pay the warranty, and they wanted that they had already put on a new cylinder and they were about to go fly. I stopped them from flying the airplane, went on site, and explained to them that this was not a defective piston. We had a detonation event. Um, Kind of peeled back the onion, if you will, and found that the mechanic had pulled the vacuum pump off, put a new vacuum pump, and got the gear turned on the magneto drive, and the right magneto was firing at 58 degrees before top center instead of 22 degrees before top center. That advanced amount of timing was enough to begin the excitation of temperature and pressure in the cylinder to fire prematurely to the point where the temperatures and pressure got to the point where the engine became a diesel, it started to detonate. That's what a diesel does. It detonates on every stroke. And so the engine was firing because of the combustion. It was a compression ignition engine at that point, and that's how the timing leads to it. It elevates the pressures and temperatures because the spark is occurring too early.
Okay. Okay. All right. Doug Fisher, let's see here. For engines that are sitting idle for days or weeks, do you advise pulling or pulling the prop through a few times periodically, or leave it static? He has been given opinions to leave the prop alone, or to turn it just to get everything fluids going.
Yeah, there's no reason for a few weeks or even a few months to have to do that. Starting the engine, going out just to start the engine, and leaving the airplane in the chocks, or pushing it outside and starting it for a few minutes, is even more detrimental. You don't want to do that. If you look at both Superior, Lycoming, and Continental, we're all in concert with the preservation documentation, and we have a preservation bulletin at our website under tech support service letters, and you can do a keyword search under preservation. But generally, if the aircraft engine is going to be sedentary for 6 months or longer, the engine should be pickled in accordance with that document. And basically what that is an oil change, the fogging of the cylinders with a corrosion preventative oil that meets a certain mil spec, and I don't recall exactly the mil spec, but it's called forth in those documents, and desiccant plugs being put in the top, and then you're good for basically indefinite storage. It goes on to talk about some of the fuel components and things like that need to be done too. But if you're going to fly it inside of 6 months, I see no reason to do any of those activities like pulling it through or anything like that.
Okay. A gentleman David has a question. Is there an issue with using MoGas in an 0470?
Well, an 0470 has a very low, it depends on the 0470 model. If it's a 470U, that has an 8.6 to 1 compression ratio, and I would avoid using MoGas in an engine like that unless you're doing it under the confines of a supplementary type certificate, and then do so under that guidance. But 470 SSRs, other models, are usually 7 to 1 on the compression, and are pretty forgiving from a detonation point in using MoGas. The problem that I have, and the problem Superior has, and Lycoming and Continental, any of us have with using MoGas, is the content of ethanol. And I know that you'll tell me, oh, but I go to this place and all they sell is ethanol, and it's 100% gas, and they advertise 100% gas. What you need to understand is that when avgas is transported, it's transported in only avgas containers. Nothing else can be put in those containers ever. When we're hauling ethanol-free gas, that tanker may have just hauled ethanol. There's no strict control of ethanol content. So if you're going to operate your engine on MoGas, I would recommend that you and that you're operating it in accordance with a supplementary type certificate. I would recommend a tester for ethanol and to make sure that it is ethanol free. The other problems with MoGas is that, in superior engines, we do and have qualified those engines on MoGas, but it's a very specific specification grade of MoGas. Just 100% gas from down at the marina or down at the place that advertise it have very varying degrees of anti-knock constituents that as compared to avgas. Avgas, if we buy it here in where I'm at in Mobile, Alabama, and I go to Seattle, Washington and buy avgas, it's going to be in the center of the goalpost, both places, for their anti-knock constituents, vapor pressure, and things like that. I don't use MoGas. I don't use it because it stinks and it can do damage to carburetor components and seals and things like that. And one of our aircraft is a Stearman with a radial engine. It's 5.4 to 1 compression. It'll run on Alabama moonshine, but we use 100 low lead in it because I know that it's ethanol free, and I know that it's the anti-knock constituents are where they should be, and avgas has a pleasant smell to me.
Good. I love it. Let's hear Jamie's got another question here. Jamie does regular oil analysis, and he's got the Millennium cylinders. On his last analysis, he had about 110 hours SMOH, and it started to show chromium in tin. AvLab says it's normal for break-in of the cylinder. Is it true? And should he be concerned or reach out to Superior?
Well, certainly if he has concern, I would invite him to call us and call me directly, and I will speak with him about that. And actually, if he wants to call me tomorrow, I would invite him to do that. Our numbers are available on the website for technical product support. It is not uncommon to see chromium levels in the break-in to be somewhat higher than the universal averages. That's not uncommon. Another thing that can affect chromium, and I learned this a couple of years ago, had a guy who had a airplane, an RV, and the chromium levels were extremely high, but the borescope inspections and compression tests weren't indicative of any type of problem. And I started researching that, and I found that painting in a hangar or adjacent hangar to an aircraft can elevate the chromium levels because the paint has chromium in it, and it can actually get into the engine through the exhaust or the intake and into the engine and get into the oil. And when we researched that, again, I don't know where I get this term, peel back the onion, but yes, the aircraft adjacent to him was just painted, and there was a lot of overspray and things like that. After a period of time, it went away and everything was normal. But that's something else that can elevate chromium. But please give me a call tomorrow, and we'll I'd like for you to email me the oil analysis. Let me look at it, just to ensure that there's nothing going on, but I doubt there is.
Okay, great. Mike Davis, he's got an 0470 in his Skyline. What EGT, CHT should he look for at cruise?
Okay, first off, there's no limit published for exhaust gas temperature on any normal aspirated aircraft engine. There are, in turbocharged engines, you do have turbo inlet temperature limitations, but those are predicated on turbocharger limitations and not on engine limitations. So peak is peak. In whatever it is you can run at peak, that's not going to be too high in your 0470. Your a general rule of thumb for uh, any aircraft engine is that it should run at a best power or at peak or lean to peak, and in a 470 it can't. But any aircraft engine should run smooth at a cylinder head temperature of less than 400 degrees in cruise. Mine, uh, our R182, I run it pretty hard, and I normally see right at 398, 400. Doesn't bother me at all. Um, I got good oil temperature, about 185. Um, Good combustion deposit signatures on borescope inspections. It's right where I want to be, and doesn't bother me at all.
Okay. Uh, Geo has a question. Well, it's interesting. He says, hello, he's got any idea if the low pressure cowl will affect cooling or higher cylinder head temps versus the standard cowl on a Comanche 260 Bravo with a Lycoming IO 540. He said his baffling is fairly new, but at different settings, he still sees high temperatures, 380 to 400.
I don't know that 380 to 400 gives me any heartburn in cruise with that particular engine. I'm not familiar with the Lopresti cowl versus the Piper cowl. Um, Again, with this particular question, I would invite him to contact me through the number at our website for technical product support. Tonight, for homework, I will research the Lopresti cowl and look at that. I'm sure it's something very similar to some of the DeShannon kits that we see in some other uh, aircraft in different cowl configurations, and it may not be necessarily the cowl, but baffling and things like that. And I can troubleshoot with them, and certainly with regards to how the baffling ought to lay, maybe, and have him send me some pictures and things like that, is probably more useful than it just being a function of the cowl difference. I'm guessing, but I'm not familiar with the Lopresti cowl.
Okay, fair enough. Merrick has a question. There seems to be a conflict between running at high recommended power versus lower recommended power levels as relating to combustion pressures. At lower power combustion pressures would be lower and oil temperature would be lower. Is Cessna wrong in allowing operating at lower cruise power?
Yes, good, very good question. And no, Cessna's not wrong in in allowing in power charts for low cruise operations. First off, combustion pressure is not a four-letter word. It's a good thing for the engine. It's a good thing for the piston rings. It is good for the engine. Just because you're running at a at max recommended cruise does not mean that you're going to reduce the engine life at all. What we have to do, though, is if we're running at lower power settings, we have to look at the leaning process. We certainly at 55% power, we may not want to run lean of peak, because then we're really too cool. We may want to run at best power or at peak to affect more heat in the engine. So, um, Cessna did not do anything wrong in that. Again, missions for photography, those types of things, flight training. If you get an IFR hold and you're low on fuel, or you're trying to stretch the fuel to set a cruise power at 55% for 30 minutes or 45 minutes or something like that, is not going to hurt the engine to do those in temporary states. It's just not something that you would do all the time, run the engine there all the time without periodically getting it up to a higher temperature where we would cook some of that stuff out of the engine.
Okay, thank you.
Mm-hmm.
Let's see here, Michael, he typically looks at BHP percent on his JPI rather than the MP RPM combination. Is that a mistake? Should it only be referring to the POH number combinations?
That's a very good question, Michael, and I have always been and have always used the RPM manifold pressure combination as opposed to the percent power. Um, I think that if something is miscalibrated or something like that, that could cause some problems. Or if you do use the percent power, I would cross-check with manifold pressure and RPM. Um, the short answer is that yeah, I would probably steer away from just using percent power and ensure that my manifold pressure RPM setting was where I wanted it, and that periodically that the RPM is calibrated. I did that just the other day on our 182, found that we're about 50 RPM off on the RPM gauge. I used a calibrated strobe tach on the dash to compare with the RPM gauge in the aircraft, and it was inaccurate. And I have an EDM 700, so it was, miscalibrated and reading erroneously. So be careful with that.
Okay, thank you. I had to go over to the Zoom chat. We have a couple of questions in the chat. This gentleman has a PA 28181 with a Lycoming 0360. I have an EGT, no engine monitor. All I have is an EGT, no engine monitor. What is the best leaning practice?
Good question, and my apologies for not covering that earlier in the presentation. I did talk about the whiz bang multi-point, but if you have just a single exhaust gas temperature gauge, you can lean that to peak as well, and find peak, and then uh, either enrich or lean from that data point. Instead of using the first cylinder peak or the last cylinder peak, you're just using the single gauge, and there's nothing wrong with that at all.
Okay.
So it's not the end of the world that he doesn't have the whiz bang stuff. Now, the engine monitor people, if you're listening, I'm not anti-engine monitor, but you don't have to necessarily have that in order to lean the engine effectively. Engine monitors have great usefulness in diagnostics and troubleshooting and things like that, but you don't need to convince yourself that you have to have that in order to run lean a peak or best power.
Okay, great. We have a couple comments on just great tips. People are liking all the stuff you're presenting over in this other area. One gentleman said he may have had to leave, but just letting everybody know that this is recorded and we will have them on the YouTube channels. Let's see here. Great seminar. I fly a PA 32-300. It's an IO 540. No GAMI. What is the normal CHT cylinder, and EGT temperature difference? And when does the difference / spread become a concern?
Okay, good question. EGT spreads, I think, something greater than 75 to 100 degrees, you may want to look at nozzles, airflow, something like that. There's an imbalance there. With EGT be nozzles with cylinder head temperatures, again about the same parameter, 75 to 100. Looking at airflow for the cylinders, if there's a varying amount greater than that. But I think a lot of times we do get very, very caught up in that we really want them to peak all at the same time and be right within each other. And the truth of the matter is it's probably not worth chasing as much. And again, the GAMI people, George Braley's a good friend of mine, but I don't want him to think that, that they make a great product. GAMI makes a great product. It'll bring the spreads closer, align the peaks, certainly. But at the end of the day, do you have to have that in order to run? No. And so if there's something outside of that, probably 75 to 100 degrees, I'd probably consult my mechanic and let him do a little troubleshooting.
Okay. A gentleman named Todd has a question. Let's see here. Lycoming's manual on an 0540 says that max power cruise, it says, quote unquote, never lean beyond 150 degrees rich side of peak, end quote, unless POH shows otherwise. If POH doesn't specify Can you comment on that? 150 seems like a lot.
Yeah, I'm not sure that I understand that question. This is an 0540, and can you read that to me one more time?
Sure, yeah.
Yeah.
Like the Lycoming's manual on an 0540 indicates or says that max power cruise, quote, never lean beyond 150 degrees PM rich side of peak, end quote, unless POH shows otherwise. If POH doesn't specify, can you comment on that?
Yeah, the POH should specify your max recommended cruise, and this is probably an example of where it's not just spelled out in a sentence what that percent power or what that is. What they're saying is that you never want to lean 150 leaner than 150 degrees rich peak unless you are identified max cruise power setting. And I believe that in that particular engine model, you're going to find that in the power chart, in the cruise power chart, and it'll have a manifold pressure RPM limit at the top of the chart, and that's going to be max cruise power setting. I've not seen an aircraft that did not have um, a max cruise power setting identified either in the chart or in the manual.
Okay. I'm kind of scrolling through this. It looks like we've hit most of the Q&As here with quite a few. I'm going back to my Q&A. Yeah, I think, let's see here. I know this could go on all night. Let me just go to the bottom of this. If you'll bear with me just for a second. Someone says, when operating lean of peak, how do you determine what the percent power is? This is from Bill.
I don't really determine that. Now, some engine monitors do have an algorithm in there that will um, tell you what that is, but um, again, we set max cruise power setting for a given altitude, and then we lean. When we lean to, we go, if we lean and we are leaner than peak exhaust gas temperature, there is a detriment to the performance. I never calculate that, because where I started, and this is a big misnomer with folks, is they think you need to capture that back or know what that number is. You need to be satisfied that in going from best power to lean of peak, in most aircraft, you're looking at a 5 to 8 to 10 knot airspeed change. You could calculate that backwards and figure about what percent power that would be, but I don't think that it's really necessary. Again, the starting point is where we're at. Same thing with max cruise power setting. If it's 75%, Cessna and Piper already know that if you lean to best power, the engine's going to be putting out 78 or 80% or something like that. All that's already done for you. Same on the lean side of peak. It's just not something I would worry about. Just lean it and be satisfied with the speed drop.
Okay, excellent. Thank you. Well, I think we've hit all the questions here. Oh, there's a new message. I'm not sure if it's a question or a message. I'm going to scroll down. Michael says, with the Trio 540, it says never to operate over 1650 TIT. How low is too low? How high is just right without wearing the turbocharger?
Well, and I think this was a Lycoming engine. Is that correct? Was it specified?
It doesn't say no.
Well, whether it really doesn't matter, but if it was a Continental or a Lycoming, peak TIT is where he would be his reference for leaning. He would lean to peak TIT, and at or below max cruise power setting, it's probably not going to exceed the 1650 degrees. And again, that's predicated on turbocharger limitations, not the engine. So at or below that max cruise power setting, it's probably going to be somewhere, the peak TIT is probably going to be very, very close to that. It's not going to hurt the turbo to see that for a few moments while we're finding peak. If it's going above that, we could have fuel delivery problems, fuel calibration problems, or something like that. If you're unable to find a peak TIT below 1650, then we probably should involve a mechanic. But there's really no how low is too low, and the top of that would be peak TIT, and we can run 75 degrees rich of peak TIT, or we can run 50 degrees lean of peak TIT, depending upon the engine. Again, I don't know what engine we're talking about, but
it's Lycoming. It is
Lycoming. Okay, well, Lycoming's probably going to want him to run very, very close to peak TIT, and at or below that setting, he shouldn't see 1650. If he is, there's probably something going on with the fuel servo, and or other things, and maybe involve a mechanic to troubleshoot.
Okay. I think that is it for the questions. I think we've hit them all.
Okay.
All those that needed the IA renewals, we know that you had to put your name in. I think Jen's been watching that for the credits on that. And if anyone has any questions, you may know how to reach Bill or reach Jen and I. We will forward questions to Bill.
Right.
And we really want to thank everybody for showing up today. This has been a great conversation again.
Yeah, thank you.
Thank you for your time as always. And for those that want to watch a little more, we have more of Bill's presentations on the YouTube channels, respectively, Piper Flyer or Cessna Flyer. You'll see his previous conversations. So thank you, everybody. We appreciate everybody. And everyone have a great evening. And thank you for being with us today at 4 o'clock Pacific time. To that, everybody say goodbye and take care.
Take care.
Bye-bye.
Thank you.
Okay. Bye, guys.
Bye.